So let's see what a problem would look like if you're taking an exam or a quiz. So for example, we have a question here. The equilibrium constant for the formation of hydrogen bromide gas from hydrogen gas and bromine gas is 2.18 times 10 to the 6 at 1003 Kelvin. Starting with 3.20 moles of HBr in a 12-liter vessel, calculate the equilibrium concentrations of hydrogen gas, bromine gas, and hydrogen bromide. First, you need to recognize that this is extraneous information. This Kelvin is not going to help us. We also need to look at what information is going to help us. So we're given the equilibrium constant. So we need to recognize that this value, the 2.18 times 10 to the 6, is the K. Next, we need to be able to write a balanced equation. So we have to look at the words and translate them into a formula equation. It says for the formation of hydrogen bromide. So that means that we would have hydrogen bromide, and it's a gas, as a product. Let's not worry about balancing just yet because we're trying to figure out what's going on here. Formation of hydrogen bromide, okay, that's our product. From, well, if it says from, then that means that this is the reactant. So we would use the word equation to write the reaction. The hydrogen gas, we know hydrogen gas is diatomic. I don't know how to do subscript on this. Okay, so you want to make sure you put your phase in because you could lose points if you don't. And of course, you will have to write the two as a subscript. Hydrogen gas and bromine gas. Okay, so bromine gas is also diatomic. And then it's equilibrium, so that means you have to draw two arrows. So one of your arrows is going to go this way, and your other arrow is going to go this way. And it doesn't matter what size you make of them, because obviously we can't make the size relative to the constant. We would run out of room. So your first task is to be really good at writing equations. Now, if you notice, it's not balanced. You're going to have to balance these also. So it looks like we need to put a 2 in front of there. There we go. Okay. So you're going to have to do this yourself. So after you do that, then you can start with your ice table underneath it. So if we look at our ice table, we have our balanced equation. So you can use this first row to do your balanced equation. Remember to put your phases in so you don't lose points. And remember to put your equilibrium arrows in. So this is your balanced equation. And then if you look at the question, it told you how much you had of the hydrogen bromide. So that's your starting. So let's go back and look at the question really fast. It was 3.2 moles of hydrogen bromide in a 12-liter vessel. And so we calculated the molarity. And that is how we got the 0.267. And remember over here, we have labeled it as molarity. We're starting with our product. We have 0 reactant and 0 reactant. So technically, the reaction is going to be going this way. You want to understand which way the reaction is going because you're going to need that in order to fill in your change. So if I'm losing product, it's going to be minus. And then we have to use the coefficient. So it's going to be minus 2x. We're gaining reactant, so that's plus x. We're gaining reactant, so that's plus x. Once you have the initial row and the change row filled out, you just follow your instructions. Just do what you're telling yourself to do. So this is x, this is x, this is 0.267 minus 2x. So now we have our equilibrium row, and we're going to use that. We set up our equilibrium expression based on our balanced equation. This is always a good idea to do. And also, let's say that you do something wrong later, this will give you more partial credit if you've done this. Once we have our equilibrium expression and we have our row that shows our equilibrium, we just have to use it and put it in where it goes. Here's our X here for bromine, our X for hydrogen, and then this was given in the problem, the equilibrium number. In this case, we could take the square root of both sides. And when we do that, that simplifies the equation, and then we can solve from X from there. So once we have our X, all we need to do is go back and look at our table and what did our X mean? Well, according to our table, the X is the equilibrium molarity of hydrogen gas. And then X is also the equilibrium molarity of the bromine gas. We're going to have to do a little math for the hydrogen bromide. So our instructions tell us 0.267 minus 2x. This is our x. We solved for that. So then all we have to do is put it in here, and then we will get the equilibrium concentration of the hydrogen bromide. So you need to know your nomenclature. You need to be able to write balanced equations, and you need to understand which way your ICE table is going as far as the reaction. And again, practice will make it better for you. I'm busy. Senor, go away, I'm busy.